So there was a problem in surface tension which came in NEET the year 2025. So there was a surface of liquid. This part was flat and this part has a radius of curvature, and I don't remember exactly. Suppose this angle is theta somehow, and this part of this vessel is very large, right? That means this part means, I mean, this width, this is very large, this is large, and so this is the surface like this. If I draw the three-dimensional diagram, this is the nature of the surface. Now I will again draw the 2D diagram of the same, and here it goes. This is the x-axis and this is the y-axis, and you know, due to surface tension, you know, say this is the height y, and if you consider this part of the surface, say we have studied it earlier that if you have a surface like this, you have two radius of curvature from two views. So one of the views, it is R1, that means I think you can guess it from here. Suppose this is a surface, okay, so this part is curved surface. If you look from this view, it has got, I mean, if you complete the circle, it has got a radius of curvature, and if you see it from here, it's a flat surface. So if you draw two normals, so radius of curvature is infinity. That means this R2 here, as this is infinitely large, that is mentioned in the problem, and this is the thing, right? See, this part is flat, so radius of curvature R2 is very, very large, and this part, it is R1. And now we have this so excess pressure. Here you have pressure P0, atmospheric pressure, and here you have P. So this P0 minus P is S into 1 by R1 plus 1 by R2. Now here this 1 by R2 is 0, so 1 by R1. So here P0 minus P is S by R1, right? And here you see this part is flat, so here R1 and R2 both are infinity in this place. So this is P0, this is also P0, and this is Y rho g less than P0. So this P pressure is P0 minus Y rho g. So rho is density of this liquid. So therefore we can write here Y rho g is equal to S by R1. S is coefficient of surface tension of the liquid, and you know the formula for radius of curvature, 1 by R is d2i dx2 by 1 plus dy dx whole square to the power 3 by 2. Here it is given that the slope of this surface is very, very small, so we can neglect this dy dx out here. So 1 by R is d2i dx2. So therefore we can write Y rho g is equal to S into d2y by dx2. So this was the question, and this is the answer. The options were given, 4 options were given, and this was one of the options. It's let me tell you, it is difficult for NEET aspirants. So if you are a sincere NEET aspirant, if you are, I mean, attending class with JEE aspirants, then you can do it. Otherwise, for typical NEET question, this is very difficult.